Hi guys, myself Pranab is here to deliver today's presentation on power transformer part 32. As of continuation, the topic is mainly comprised of bushing technology for power transformers. For your convenience, the link of the previous one is given under the description box. Now, let's start with assessing the quality of insulation of condenser bushing in terms of dielectric loss. Number one, insulation performance of the condenser bushings active part is directly affected by the combined effect of electric field, thermal configuration, and moisture content. Number two, any increase of capacitive current value that indicates an obvious degradation in the active core insulation system, and there might have been some shorted layers or certain ingression of moisture or some basic changes in the geometry of the insulation system of the bushing. The resistive current that implies the loss of energy due to dielectric losses such as carbon tracking, volumetric leakage, surface condition, and corona. Number four, impurities, if present within the insulating medium, that has to create dielectric losses, and a resistive current is thus to be introduced, which causes the current to deviate from the ideal 90-degree phase shift from the applied voltage. Number five, dielectric losses as due to ingress of moisture or carbon tracking or volumetric leakage or surface conduction, etc., would have to increase by the square of the operating voltage. Again, I repeat, dielectric losses as due to ingress of moisture or some carbon tracking or volumetric leakage or surface conduction, etc., would have to increase by the square of the operating voltage. But in case of corona, the dielectric loss would have been increased exponentially as the operating voltage increases. Any increase in dissipation factor, that is tan delta, is a clear indication of deterioration of original insulating quality of a material used for the active part of the capacitor graded bushings, that is condenser bushings. Condenser bushings, as being located at outdoors, and the condition of environment may be different from test to test. So, the electrical characteristics of most of the insulation materials would have to vary with prevailing temperature and humidity, along with cleanliness of the insulation surface. As the diagnostic measurement is directly influenced by the surface leakage current, and that also depends on the cleanliness of the insulation surface, the relative humidity and temperature. Again, I repeat, as the diagnostic measurement is directly influenced by the surface leakage current, and that also depends on the cleanliness of the insulation surface, the relative humidity and temperature, that is atmospheric temperature or the environmental temperature. Number 10, insulation of most of the materials as corresponds to their electrical characteristics would generally have to vary with temperature. So, establishing a trend of power factor test measurements for assessing the service quality of insulation of condenser bushing, it is of much more necessary to convert the test results taken at different temperatures to have a common base temperature, and that is to be recommended of 20 degrees centigrade. Power factor measurements at different temperatures should therefore be corrected to a value of 20 degrees centigrade by multiplying with the correction factor K, and correction factor chart would have to be supplied by the original equipment manufacturer. Therefore, power factor at 20 degrees centigrade equals to power factor at T degrees centigrade, that is the environmental temperature when measuring the PF, into K, where K is the correction factor for 20 degrees centigrade conversion. Condition assessment of aged bushings through dielectric frequency response method. Bushings obviously are designed to withstand high voltage stress along with high amount of current to carry and thus to operate all through under high temperatures. But as their external hub are always being exposed to atmospheric conditions, so health of their active part insulation needs to be periodically monitored during its service life, and for which several online and offline testing methods can there be implemented. However, for early detection of consequential deteriorating factor as developed within the insulating structural components of condenser type of bushing, it has been technically evident that the most effective diagnostic tests is dissipation factor test. Dissipation factor or power factor test is the process of measuring capacitance and dielectric loss at rated frequency, and from which overall condition of the insulation can easily be assessed, as because it is we are discussing about the capacitance graded bushings. Therefore, capacitance and dielectric loss both are very important for assessing the insulation condition. For bushing diagnostics, as in recent times, dielectric frequency response methods by using polarization or depolarization current and frequency dielectric spectroscopy have been established an effective application of power factor testing to evaluate the aging status of the oil and paper insulation of the OIP, that is oil impregnated paper bushings, capacitance graded bushings. Normally, power factor testing, whether be at very low frequency, it is preferable to apply dielectric frequency response method by using polarization, depolarization current method. Again, I repeat, normally power factor testing, whether be at very low frequency, it is preferable to apply dielectric frequency response method by using polarization, depolarization current method, that is PDC method. To evaluate the exact status of HV condenser bushings and to have comparative signature analysis for their core insulation behavior in the entire range of frequencies, which thereafter would have to be compared with conventional test results, it has been observed that the best possible technically accepted diagnostics method is to apply dielectric response method by using both PDC and FDS. FDS means frequency dielectric spectroscopy testing procedures. Frequency domain spectroscopy measurement, which has to be achieved at wide frequency band with its detailed, reliable analysis and interpretation scheme, is thus proved to be an useful tool both at factory and also at site as a non-destructive test to review the insulation status of high voltage or extra high voltage condenser bushings, where frequent oil sampling is difficult to conduct or not to be recommended for obvious reasons. Measurements at site for power factor and capacitance grading may have to differ from measurements made under the controlled conditions in the factory. It is just because the electrical noise at site is much more, but whereas in the factory state, the environmental electrical noise should be arranged to minimum level. So the measurement of power factor and capacitance at the time of installation should have to be kept as the reference value for comparative study with future measurements. Constant framing of the trend analysis that will readily indicate Bushing's health condition. Constant framing of the trend analysis that will readily indicate Bushing's health condition. Analyzing the aging characteristics of OIP bushings. OIP bushings is therefore is mostly used in high voltage and extra high voltage system. Oil paper insulation aging characteristics is of much importance to assess the insulation conditions as relate to the core of the bushings with grading foils. Grading foils means capacitance grading. Aging in the paper insulation becomes crucial for the life of high voltage OIP condenser bushings. Paper insulation, as comprised of cellulose, has lost its prevalent dielectric strength and the degree of polymerization over time due to have certain combined effect of oxygen, temperature, water, or moisture, or acid, out of which water element in the cellulosic insulation would have been the most critical factor, as because the existing water content causes hydrolysis, which in turn produces more water as a result in this chemical reaction. The degree of polymerization is thus to be accelerated with degree of thermal and electro-thermal ambience. However, it has been exhibited that degree of polymerization of the innermost and the outermost layer paper would have become much faster than that of the middle layer paper. Again, I repeat, it has been exhibited that degree of polymerization of the innermost and the outermost layer paper would have become much faster than that of the middle layer paper. In the OIP bushing, the insulating structure has been competently designed with the perfect combination of oil, paper, and conducting foils located between the insulating papers. Such structural configuration might have been effectively fulfilled an uniform distribution of electric field within the condenser core. But the characteristics of conductive foils would constantly have to impose some influence on the combined characteristics of oil and paper insulation. Again, I repeat, the characteristics of conductive foils would constantly have to impose some influence on the combined characteristics of oil and paper insulation. As of the configuration of OIP bushings, the innermost layer of the insulating paper is in contact with the copper conductor, and the outermost layer of the insulating paper is in contact with oil. So, over time of operation, there would have been a possibility of easy absorption of copper ions and mixing with the products dissolved in the oil. Eventually, this process would have been further accelerated with rise of temperature and time, which ultimately forced to degrade the properties of oil and paper insulation. In the OIP condenser bushing, the acidity and dielectric loss of oil will also be enhanced with aging time, as because oil paper insulation would have been gradually oxidized to generate a series of aging products. These aging products with strong polarity have also much responsible for affecting the dielectric properties of insulating oil. From statistical data, it can be concluded that there are three main predominant factors causing the deterioration of oil paper insulation. A. Thermal degradation. B. Hydrolysis. And C. Oxidation degradation. As per IEC standard 60137, oil impregnated paper bushings is classified under Class A insulation and ranges up to 105 degrees centigrade. While the bushing is under operation, the heat as produced is to be accumulated around the conductive rod. Rate of failure of the crucial insulation part of the internal capacitor core is of much more dominating among all of the parts of the capacitive bushings. Basically, the moisture absorption ability of kraft papers, that is cellulose type, is much more stronger than that of the insulating oil. Moisture in combination with temperature has therefore to expedite the aging characteristics of oil paper bushings. It has been exhibited that at about 130 degrees centigrade temperature, with having moderate moisture content on the internal capacitor core surface, then thermal aging of the insulating part would have been accelerated in a much faster rate. By measuring only by integral value of dielectric dissipation factor, tan delta, might not be sufficient to reflect the actual aging degree of oil paper bushing. Aging characteristics is thus to be assessed through periodical measurement of the moisture content, degree of polymerization, and frequency domain dielectric spectroscopy. The conventional tests such as dissipation or power factor and capacitance measurements would have been carried out only at mains frequency, that is 50 Hz frequency, for finding out the condition and the aging state of the bushing insulation system. As the measurement is at single frequency, so only for a limited assessment of the insulation condition can be made to fulfill. But the dielectric spectroscopy methods can be employed for a wide range of frequency, which has enabled to reflect a discrimination of the various effects as of different causes. Dielectric spectroscopy techniques and frequency domain can be applied to measure the OIP condenser bushings, capacitance ratio, and direct current conductivity. Both the parameters, if accurately measured, would have to indicate the exact insulation condition of OIP condenser bushing, and the parameters are once to be increased with moisture or aging duration. Degradation of OIP bushings due to partial discharge. High voltage bushings are used to insulate high voltage conductors and act as a crucial accessory of power transformers. As the bushing is an integral part of this vital equipment, so its internal and external insulation would be such that must have to ensure the withstanding reliability of all sorts of electrical, thermal, and mechanical stresses under extreme conditions. Partial discharge would have to occur when a small area of insulation in a high voltage environment cannot cope with the electrical stress. The energy as emitted by the PD activity may cause insulation to deteriorate over time, which will ultimately lead to failure. Bushing must be designed to withstand underneath stresses. 1, electrical stress. Number 2, mechanical stress. Number 3, thermal stress. And number 4, ambient stress. These different sources of stresses are responsible for degradation of insulating material. Mechanical stress is thus to be countered by providing sufficient mechanical strength to have a proper support of the conductor, as well as all sorts of external connections, including under short circuit and possible seismic forces. Proper thermal designing of the bushing may have to get out of the overheating problem of any of its components, which would also help to restrict the onset of aging phenomena within its insulation, both at rated current and during short circuit events. Bushing must have to withstand underneath sources of electrical stress. 1. Partial discharge, electrical tree, depolymerization, increased moisture. These four are very important. Out of which the analysis of partial discharge phenomenon in oil impregnated paper bushing is very much inevitable, as because this will help the designers to eradicate the causes of defects during design and manufacturing stage. Partial discharge would have to occur when a small defective section of a total insulation unit in a high voltage environment cannot cope with the electrical stress, which results in complete breakdown of insulation of that section. At different locations and mediums in high voltage environment, such repetitive discharges may ultimately propagate to catastrophic failures of bushing insulations over time. For outdoor application, the OIP bushings are configured with insulators both at air and oil ends, thus forming an insulating envelope and the intervening space between condenser core and external insulated body may be filled with specially treated mineral oil under vacuum or other insulating medium. Case of insulation flashover might have been averted by carefully determining the following factors. Number 1, basic profile of the dielectric characteristics of insulating material. Number 2, mounting arrangement of the bushing insulator, such as vertical, horizontal, or inclined in certain angle. Number 3, properties of the insulating surface, such as hydrophobicity or toughness, etc. Number 4, depending on the pollution levels, that is environmental pollution, a minimum specific creepage distance is to be judicially maintained for air and side insulators, such as pollution level. If it is minimum 16 millimeter per kV, medium, pollution level medium, then 20 millimeter per kV. If it is high, then 25 millimeter per kV, and in case of very high, 31 millimeter per kV. The creepage distance, specific creepage distance, minimum. But characteristics of partial discharge are quite different from direct insulation flashover phenomena. Again, I repeat, characteristics of partial discharge are quite different from direct insulation flashover phenomena. Basically, these are the localized electrical discharges at the specific defective zone within the insulation system, where every discharge event may have to affect the existing dielectric properties of that section due to energy of impact of high electron or high electrode ions, causing several types of chemical transformation. The repetitive impact of discharges within solid dielectrics would have to form certain discharge channels within the insulation, which is called treeing effect. If there is any process flaw in impregnation of papers and certain gas evolution would there have been taken place during electric stress, then cause of occurrence might have been as because of partial discharge. Such happenings would force to accelerate the aging process of the bushing dielectric system. Let's stop here. Further to be continued at later stage. Thank you. Thank you for listening the video. Kindly do like, share, and subscribe. Your subscriptions would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section. Thank you. Thank you for patient hearing.